Now, yesterday we started talking about rotations. All right, so typically a rotation is literally you're just turning a shape. All right, so rotations, you're just turning the shape. So yesterday we talked about if we wanted to move one point to another point, and we talked about how direction matters. All right, does anyone remember the only degree measure where you don't have to specify whether it's clockwise or counterclockwise?
180.
180, good. And why is it 180? Well, yeah, but why is it 180 degrees? Like, why specifically is that the special number?
Because it's the same distance.
Right, because 180 is essentially half of a circle, because a circle is 360 degrees. All right, and if you're rotating something, you're literally going around in a circle. All right. Now, so in other words, we just did a very simple one where they said, okay, if we're mapping E onto H, what are the two ways we can get it? So we went from E to H counterclockwise, that is 121. If we went from E to H on the other side, that is whatever 95 plus 54 plus 90 is. All right. So that's a very, very simple rotation. Now remember, what I said in this class is that when it comes to rotations, it's always going to be in increments of 90. All right. And why do you think we only care about increments of 90? Especially if you're dealing with graphs. Why do you think we're only dealing with increments of 90 degrees?
It's like 90 times 4 760. It's like 4 parts.
Right, that's part of it. But think about the shape of this graph specifically. What's so special about coordinate plane that makes 90 degrees easy for rotations?
It's a right angle.
Right. So if you look at a graph, every quadrant on this graph forms a 90-degree angle. And there's 4 quadrants, so it adds up to 360 because 4 times 90 is 360. All right. So that's why when we do 90-degree increments, that's what we mean. All right. So this next example is one where you might want to use your patty paper. All right. So example A states if E, F, G are at these points, and they already plotted for us. They want to know where E prime, F prime, and G prime will be if we rotate 90 degrees clockwise about the origin. All right. Now, let me ask you this before we get started. If we're going 90 degrees and we're going clockwise, first off, which direction are we going in? Am I going to go right or am I going to go left?
Right.
You're going to go right. All right. So in this class, if you ever forget which way is clockwise, which way is counterclockwise, all you need to do, look at that clock. Whatever direction that red hand is going in, that's clockwise. Backwards is counterclockwise. All right. More often than not in this class, you will be going counterclockwise, but you still got to be prepared for the eventuality that you go clockwise. All right. Now, before we even get started, let me ask you this. If I go 90 degrees clockwise, what quadrant is F in? Which quadrant is F in? So 1, 2, 3, or 4? It's in quadrant 2. So if I go 90 degrees counterclockwise, not counterclockwise, sorry, 90 degrees clockwise, what quadrant would it end up in? 1. So F will be in 1. What about E and G? What quadrant are they in? Currently.
They're in 1.
They're in 1. So if we go 90 degrees clockwise, where will they end up?
2.
Nope. That's 4. Clockwise, they'll end up in 4. If it was counterclockwise, they end up in 2. All right. So what I want you guys to do is take your patty paper and you're going to. So this isn't patty paper, but what you're going to want to do is put it over the shape and trace it completely. All right. Then it should be big enough that you can stick your finger on the origin and see it. And then just rotate it so it's on its next side and see where the points line up. All right. So take a minute and do that. So again, before you rotate it, you need to put your finger on the origin, because remember it's saying about the origin. So the origin is the center of the circle. All right. So take a moment and do that. So in other words, see if you can figure out where the points will end up. So again, let's do this together. All right. So we're going about the origin. So I would even make the dot on your patty paper where the origin is, just so you know where it is.
Right here.
All right. So I went ahead and I drew this on my patty paper. Okay. Now, this is obviously just regular paper for me, but same thing. You can still see it. So what you're going to do is, once you draw it on your patty paper, make sure it's labeled F, G, and E, so you know which point's which. You're going to take your finger, and you're going to put it on the origin. And then you're going to move the paper, holding it down at the origin until it's 90 degrees. All right. Now, mine is not perfect, but yours should be, because you have a square. All right. So again, line it up. Put your finger on the origin and then move it 90 degrees until your paper is leveled out again. All right. And again, mine is not perfect, but yours should be. This is square. Once you think you've got what the new points are, write it down. So let's do this together. So everyone look up here. So I actually went and I made square paper real quick just so it works out. I put a magnet on the origin. All right. So I'm going to hold this magnet down while I move the other one around 90 degrees. All right. So all right. So let me ask you guys this. When you did that, what point did you end up at? So for F, we know it has to end up somewhere in quadrant 1. So it's originally at the point 3 or negative 3/8. All right. So another way to think about this is that if I draw a circle, all right, where the origin is the center, all right, let's just say that I took a piece of string. All right, so let's just say I took a piece of string and my origin's my center, all right, and I made the length up until it hits point F. All right, so I got it pulled tight all the way to point F. And I'm going to go 90 degrees from the origin. So I'm just going to circle it. All right. And then F should end up right here. Right here. So that's 90 degrees away from F. So what's that point? So F ends up right here. So what is that? 8,3. All right. So F prime ends up at 8,3. So F prime ends up.
Quick question to you, huh?
Uh-huh. Uh-huh.
Why don't I have a reflections folder?
You should.
I don't.
That's weird.
Do you?
Yeah.
Double check.
There you go.
Wait a minute. Did you just label it funny? 1.3.
Yeah, it's 1.3.
But it should be 1.2. No,
It's
1.3.
It's 1.3.
Oh, we don't have a translations one.
Right. Yeah.
We don't have a translations
No.
one. Okay.
So this ended up at 8,3. Now, for timing's sake, G ends up at, so if I make a circle and I go all the way around, G will end up at, will end up at 3, -4. And E will end up at 2, -1. So another way we can think about it is let's say that I drew a circle with my center at the origin and I zoomed it out. Okay, no. All right, you know what? Yeah, I'm just going to give you the points. Make your life easier. Okay, so the new points are E prime is at 2, -1. F prime is at 8, 3. And G prime is at 3, -4. So here's my question to you. Based off of those points, what do you think my rule is for going clockwise about the origin 90 degrees? So look at the original points up here. What happened between the original and the new? So if we look at the original, what happened?
The coordinates flipped.
So the coordinates flip. So the first thing that happens is we have yx. What else happened?
The signs changed.
For which one? For the y, or our new y value. So our original x value, the sign changed, but it's our new y value. So we would put a negative in front of this x. All right. Now, if we rotated clockwise, okay, and I'm just going to give you these points. All right, but just know if you rotate it clockwise, this is what would happen. You would get E would become -2, +1. So that's E double prime. So E double prime is -2, +1. F double prime would be -8, -3. And G double prime would be -3, +4. So first off, does that make sense? So if I do 90 degrees counterclockwise from F, if F is in quadrant 2 originally, what quadrant does it end up in counterclockwise? If I go counterclockwise, I'm in quadrant 2, so where does F end up in? Quadrant 3. For E and G, they're still in quadrant 1, so if I go 90 degrees counterclockwise, where do they end up? Quadrant 2. All right, and that's what happened here, so that makes sense. So, what happened? So, rule-wise, what happened from our original points to our new green points? What happened? So look at the original points that are highlighted up top. So for example, E. What happened between E and E double prime? What happened to the numbers? They flipped. So first part is that instead of x, y, we have y, x. What also happened? So like from E to E double prime, what also happened? Did any signs change? You sure? So E is at the point 1, 2. E double prime is at negative 2, 1. Did signs change?
Yes.
Yeah, which one? What number? The 1 or the 2? The 2. So the 2 currently is in the x value. So that means this becomes negative. Now, here's my question for you. Think about what we know about what type of points are in each quadrant. So in quadrant 1, the x and y values are both what? So if I was to plot a point in quadrant 1, what would be the signs for the x and y value?
They're both positive.
They're both positive. Quadrant 2, what are the signs? If I plot a point. Negative, positive. Quadrant 3,
Negative, negative.
negative, negative. And quadrant 4, positive, negative. Now, why am I asking you guys this? Look at the connection. So for example, if we look at point E, it's in quadrant 1. So that's a good kind of seeing where the rule falls. If we went clockwise, we end up in quadrant 4. Do you guys see a connection between the rule that we came up with and the signs we're supposed to have in quadrant 4? So look at the rule. Look at the signs that are supposed to be in quadrant 4. What do you guys see? No, besides Owen. What's the same? It's positive, negative, right? Yeah. So quadrant 4 became positive, negative. The only thing that happened was that the values flipped. What about when we did clockwise? So clockwise, E ended up in 2. What's true about the signs for quadrant 2 and the rule we came up with? What's true about the signs? They're still negative, positive. All right. So rotations are not that hard because what I'm getting at is that all you got to do, even if you don't remember the rule, depending on what direction you're going in, all you got to do is every 90 degrees, flip X and Y, change the signs to fit the quadrant. All right. All you got to do is know which quadrant they will end up in. All right. So if you're going 90 degrees counterclockwise and you start in 2, you're going to 3 next. All right. So if you started out with a negative, positive, it becomes negative, negative. All right. Now, are they congruent? Yes, they're congruent. Because why? Why are the rotations make congruent figures? We talked about this last week. Or earlier this week, actually.
The size doesn't change.
The size doesn't change, neither does the shape. But why? Rotations are a what? Starts with an R. They want to remember the word that describes a rotation, what type of transformation it is. It's a blank motion. What type? Rigid motion. Good. So remember, rigid motion means the orientation and the position just changed, nothing else. So, let's look at this figure. So just for our sanity, we're going to name these points A, B, C, and D. Now, they first ask us to rotate this figure 90 degrees clockwise. So we're rotating 90 degrees clockwise. So, before we even rotate, let's discuss. For A, if I'm rotating 90 degrees clockwise, so that means we're rotating this way. All right. What quadrant will A end up being in? If I go 90 degrees. So look at which quadrant it is, and we know it's going to go to at least one quadrant over because it's 90 degrees. What quadrant is going to end up in? Someone besides Owen. He's carrying y'all. Come on. 1. So A will end up in quadrant 1. So if we follow what I said, so remember, for every 90 degrees, flip X and Y and change signs to fit the quadrant. All right. So if A is originally at the point -3, 2, where do you think A prime will be at? So flip X and Y first. So if I flip X and Y, what's the flip of X and Y for A? 2, 3. Well, 2, -3. And then if I change the signs to fit the quadrant, what has to be true about quadrant 1? The signs have to be both what? Positive. So this would be 2, 3. So 2, 3 is where A prime will be. Now, both B and C are on the x-axis. So if we rotate 90 degrees, where would it fall on? So if it's on axis, if I rotate 90 degrees, where will it end up? Come on, guys, give me something. You got to participate or I want to start randomly calling names. So if it starts on the x-axis, where will it end up if I rotate 90 degrees? The y-axis. Now, is it going to be the top of the y-axis or the bottom of the y-axis? The top. All right. So these points are originally at -4, 0 and -2, 0. So where would B prime be? If I know it needs to end up on the top of the y-axis. All right. So think about what numbers are on the top of the y-axis. And you're still flipping X and Y. So what do you think the new point would be? 0, +4 for B. What about for C prime? 0, +2. Finally, D. D is at the point -3, -2. So if I rotate 90 degrees clockwise, D is currently in what quadrant? So what quadrant is D in? 3. So if I go 90 degrees clockwise, where would it end up? Quadrant 2. So think about what the signs are for quadrant 2. So if I flip X and Y and change the signs to fit the quadrant, what would it be? So we know it's going to be some version of 2, 3. But what would the signs look like if it's going in quadrant 2? Backwards. -2, +3. Now, so -2, +3. Yes. That's D prime. All right, so our circle will look something like this. Now, we're then going to go 180 degrees. So remember, 180 degrees, we don't have to dictate what direction because they'll end up in the same spot. But how many sets of 90 is that? 2. So let's just say we continue on with the clockwise track. All right. We already went 190. So now we just need to go another. All right. So we're going to take our A prime, our prime points, and use that to go another 90 degrees around. All right. So if A prime is at 2, 3, so it's in quadrant 1, where would A double prime end up if I go another 90 degrees clockwise? Where would it end up?
3, -2.
So end up at 3, -2 because we switched the XY back and then we changed the signs to fit the quadrant. So it'd be 3, -2 because it ends up where? What quadrant? 4. All right, so just so you have it, if you have a graph, just go ahead and mark all the signs. Just so you can get an idea of, okay, if it ends up in this quadrant, it needs to have both of these signs present. All right. So A double prime is at 3, -2. All right. What about B and C double prime? So they're on the y-axis currently. And if we want to go 90 degrees, where will they end up at? Right, so they'll end up on the x-axis, and it'll be on the right side of the x-axis. All right. So for B, it would be 4, 0. So we just switch x and y. Since I know it's going to be on the right side of the x-axis, it's positive. So that would be B double prime. What about C double prime? Where would it end up? 2, 0. And then lastly, D double prime. So D is currently in, or D prime is currently in quadrant 2. So if I rotate another 90 degrees to make it 180 degrees with the original, where would it end up? 3, -2. 3, -2. Well, not 3, -2. It'd be positive 2 because it ends up in what quadrant? 1. So guys, these are things that you have to be asking yourself as you are going through rotations. Rotations are pretty easy, even though they look complicated, just for the sheer fact of you just got to know, okay, every 90 degrees, I flip X and Y. All right. And I change the signs to fit whatever quadrant. So you got to ask yourself, okay, if I am trying to rotate D 2 quadrants away, counterclockwise, that means if I count 1, 2 quadrants, that's 180 degrees. That means I'm ending up in quadrant 1. All right. And then you ask yourself, okay, I flipped X and Y, so that'll be YX. Flip it back, XY. All right. Does that make sense so far? I know I'm kind of like botching this a little bit. All right. So lastly, we're going to go one more set of 90 degrees. So 270. So 270 is 3 sets of 90. All right. So we're going to call these triple primes because we've rotated 3 times in sets of 90 since the original. So using 180 as our reference, we're just going to go another 90 degrees clockwise. So starting with A. So A double prime. Where is it currently? What quadrant? 4. It's in quadrant 4. Where's it going to end up if I go another 90 degrees? Quadrant 3. So that means both signs are going to have to be what? Negative. And then what do I have to do? Flip the X and Y. So I now have 2 here and 3 here. This will be -2, -3 for A, triple prime. What about B? B is on the x-axis on the right side currently. So if I go another 90 degrees, where would it end up? So if it's on an axis, it's going to end up on another axis. So if it's currently on the x-axis, another 90 degrees is going to be where?
On the y-axis.
On the y-axis, top or bottom of the y-axis? Bottom. So that means that the y value specifically will be what? If it's on the bottom of the y-axis? Negative. And we know we're going to have a 0 here. And then we switch to x and y, so the 4 will be there. Same thing for C, since it's on the y-axis, we flip it, and it'll be on the bottom, so that 2 is negative. So there's C triple prime and B triple prime. Lastly, D. D double prime is in quadrant 1, so if I go another 90, where would it go? It would go into the 4th quadrant. So 4th quadrant, what's true about the signs? What do the signs have to look like in the 4th quadrant? Positive, negative. So the y value is negative. And then what do I have to do? Flip the x and y. So this would be 2, negative 3. All right. Now, we kind of already filled in this table, so you don't need to worry about the table because I wrote it to the side. All right. So, here's my question. If we want to write a rule, okay? So if we want to write a rule, so let's go 90 degrees first, clockwise. From the original to the primes, what happened? What happened to the numbers? So they flipped, so x and y flipped, and then what sign changed specifically? The x value flipped. All right, so, or it's actually the y value flipped. Yeah, the y value flipped. So the rule for 90-degree clockwise is you flip x and y, and the new y value becomes negative. Now, if I look from the original to 180 degrees, what happened? Did x and y flip, first off? From original to here, did the x and y values flip? No. What's the only thing that changed?
The signs.
The signs, and what signs? So for example, look at D. What happened between D and D double prime? So it went from -3, -2 to 3, 2. So the signs changed for both. So the rule here would be -x, -y. So they don't change. They don't flip x and y, but they do change signs. And then finally, 270. So look at the original versus 270. All right. What happened to the signs? Or what happened to the points?
The coordinates stayed the same and the signs flipped.
So the coordinates actually did flip. But what sign specifically changed? So the sign that changed specifically was the original y value, the new x value. Now, here's another way you can think about it. We know for every 90 degrees we're going to have to flip x and y. So, quadrant 1, all right, that's kind of like the standard. It's, quadrant 1's the standard because that's when everything's positive. All right. So if I go 90 degrees clockwise, where does quadrant 1 end? So this point will end up in what quadrant? 4. So 90 degrees, it would end up in quadrant 4, and that's clockwise. If I go 180, how many quadrants is that from the original? 2. So I count 1, 2. So I end up in what quadrant? 3. And we know we flipped x and y again. If I go 270, how many quadrants is that?
That's 3 quadrants.
So I go 1, 2, 3. So what quadrant is this? 2. So here's my question. Look at the rule and look at where they ended up if it was in relation to quadrant 1. What's true? The signs are the same. So if you look, 90 degrees clockwise, they end up in quadrant 4. Positive, negative. Positive, negative. 180 degrees ends up in quadrant 3. The signs should both be negative. Negative, negative. Quadrant 270, that's 3 quadrants away. It ends up in quadrant 2. Negative, positive. Negative, positive. All right, so all of these rules are made up in relation to quadrant 1. So that's why I say, like, flip, you just have to flip every 90 because that's the only thing that's consistent. Every 90 degrees it flips. All right. But that's why I say all you have to do is just change the signs to fit the quadrant because that's essentially what they're doing. All right. Does that make sense to everyone? All right. So here's my question. We already know that clockwise is going this way. So in other words, I'm going from 1 to 4. But if I want to go counterclockwise and I start in quadrant 1, so 90 degrees counterclockwise would be where? From quadrant 1? Quadrant 2. So 90 degrees counterclockwise is the same thing as what degree clockwise? 270. So 270 degrees clockwise is the same thing as 90 degrees counterclockwise. If I go 180 degrees, so 2 quadrants away, I still end up in quadrant 3. So 180 in either direction is just 180 degrees. If I go 270 counterclockwise, I go 3 quadrants away. So I would end up here. So that's the same thing as what clockwise? How many degrees clockwise? 90. So all right, so that being said, let's see if we can fill in this table knowing the rules that we know. So remember, you're just flipping x and y every 90 degrees, changing the signs to fit the quadrant depending on what direction you're going in. So let's do the point 1, -2. All right, so 1, -2, that is in what quadrant originally?
Quadrant 4.
It's in quadrant 4. So it's in quadrant 4 originally. So look at where quadrant 4 is. If I go 90 degrees clockwise, which would follow the path of the black arrow, what quadrant do I end up in?
Quadrant 3.
3. All right, so this is going to end up in quadrant 3. So that means that both signs will be what if they're going in quadrant 3? Negative. And then what do I have to do? Flip x and y. So this will be 2, 1. So now, if I go 180 degrees clockwise, how many quadrants is 180 degrees? So how many quadrants do I have to go through to get 180 degrees?
2.
2. All right, so if I start in quadrant 4 and I go 2 quadrants, what happens? If we end up in quadrant, which one? This is 2. So remember, top right's always 1, and then it goes 2, 3, 4. So we end up in quadrant 2. So what do the signs look like? Negative, positive. Now remember, this is what you need to ask yourself. All right, so we start here, we're at xy. Go 9 degrees, we're at yx. Go another 9 degrees, where am I back at? It's going to be yx or xy? Xy. So I flip the numbers back. So this would be 1, 2. Yes. Yes. Now, if I go 270, all right, so 270 degrees clockwise, what quadrant do I end up in? So I'm starting at 4. How many quadrants is 270 degrees? It's 3. So 1, 2, 3. So where do I end up in? Quadrant 1. So what do the signs look up like for quadrant 1? Positive, positive. So if I start with my original, I'm in quadrant 4. We're at xy. 1 quadrant, yx. 2 quadrants, xy. So another quadrant would be
YX.
yx. So I'm at 1, 2. So I got to flip it back to 2, 1. So is everyone understanding what I'm doing? All right. Now, counterclockwise, we technically already found the points. Okay, so we start in quadrant 4 and I go counterclockwise. What quadrant do I end up in?
Quadrant 1.
Quadrant 1. All right, and what did we say the point was for when we go to quadrant 1? 2, 1. Easy peasy lemon squeezy. What about 270? So that's 3 quadrants away from 4, counterclockwise. So 1, 2, 3. So what quadrant do I end up in? 3. And what was the point when we ended up in quadrant 3? Negative 2, negative 1. So what I want you guys to do is fill in the rest of this table. Take a minute, fill in the rest of this table. So think about what quadrant the point is in originally, and then go in the direction they want. And I will be calling people randomly to get points, so make sure you're working through it. Don't raise your hand. So guys, a strategy that you might want to use when you're doing rotations, you don't have a graph in front of you. Maybe just, in the top corner of your paper, just draw a little sketch. Be like, okay, this is quadrant 1, 2, 3, 4. And then just label what the points would be. So negative, positive, 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 negative, negative, negative. All right. Whenever you do rotation, that should be kind of what you have on your paper, even if you don't have a graph on your paper, just so you can just use it and be like, okay, I know this point's going to be in quadrant 1. I'm going 2 quadrants away counterclockwise, so 1, 2. All right. That's the way that you can think about it. All right. Yes, ma'am. So you just went clockwise. Starting. All right, so for time's sake, let's come back together. So first off, this next point, what quadrant is it in originally?
Quadrant 1.
It's in quadrant 1. So let's go with Carolina. If I go 90 degrees clockwise from quadrant 1, what quadrant do I end up in? 4. So what would the new point be? 5, 0. Good. So even though it's in quadrant 1-ish, intercepts are weird, all right? So if it's a y-intercept, it'll just end up like whatever direction, whatever x-intercept number is. Yes. All right. So let's go now 180 degrees. So let's go Nick. So 180 degrees clockwise from the original point. So if I'm in quadrant 1, we'll be 180 degrees away. What quadrant would I end up in? 3. So what's the new point? 0, -5. Good. Okay, let's go Luke. He's in the bathroom. So let's go, not here, Ralph. So 270 degrees clockwise. So if I was originally in 1, 270 is 3 quadrants. So what quadrant do I end up in? Well, think about it. So 1 clockwise, so that's 1, 2, 3. So what quadrant is this one? Second. All right. So what's the new point? -5, because that's the original point, and then 0. 9 degrees counterclockwise. We technically already found this point, not here. Bathroom, not here. So Riley E. 9 degrees counterclockwise is the same thing as which point that we already found? Not quite. So remember, 180 is always 180, whatever direction. So 90 degrees counterclockwise would be what clockwise? Right, so it'd be the same thing as 270 clockwise. So my point would be what, Riley? Good. Last one, 270 degrees counterclockwise. Let's go, Kyrie. So 270 degrees counterclockwise is the same thing as what degree clockwise? So 270 degrees counterclockwise is the same thing as what degree clockwise? Right, so it's the same thing as 90 degrees clockwise. Good. All right. Last one. So let's go Addie. So first off, we know that -3, 4 is in what quadrant? 2. So if I go 90 degrees clockwise, what quadrant will it end up in? It'll end up in 1. So what would my point look like? 4, 3. Good. All right, let's go with Abigail. So 180 degrees, that's 2 quadrants away. So if I start in 2, I'll end up where? In 4. And so what will my new point be? Good. All right. Riley M, 270 degrees clockwise. So I start in quadrant 2. So if I go 3 quadrants away, what quadrant do I end up in? We end up in quadrant 3. So what's my new point? Yep, -4, -3. All right. Wendy, 90 degrees counterclockwise is the same thing as what degree clockwise? Not 90. 270. So what's the point? Good. Micah, last one. So 270 degrees counterclockwise is the same thing as what degree clockwise? 90. So what do we get for 90 degrees clockwise? So if 270 degrees counterclockwise is the same thing as 90 degrees clockwise, that means the point is the same. So what point did we get? 4, 3. Good. All right. Now, the last thing we're going to talk about today, and then I'll call it quits because we're almost out of time. All right. So another way to write a rotation is capital R. Now, if you see a positive, let's actually make it 90. If you see a positive 90 degrees, that means counterclockwise. But if you see a big R with a negative 90, so you guys know how we've always said that you can't have a negative angle? Yeah, we lied. There are instances where you can have negative angles, but it's more so as a concept in terms of direction. So the negative is not actually like negative space, it's more so telling you the direction. So positive angles on a graph mean you're going counterclockwise around whatever point. Negative on a graph means you're going clockwise. So the standard, just so you know, the standard is counterclockwise. So unless it doesn't it should always specify, but if it doesn't, assume it's counterclockwise. So in other words, if we start in quadrant 1, for every 90 degrees, we would go 2, 3, 4. Whereas clockwise, it would be 4, 3, 2, 1. So that's the way you can remember it. Counterclockwise is forwards, numerically. Clockwise is backwards, numerically, in terms of the quadrants. Any questions on that? All right, so there is a delta map already open, but I will give you time to work on it tomorrow as well because we didn't quite get to the last little piece of 1.4, which is the symmetry part, which we'll go through tomorrow. That's quick. So if you want to start the delta map, though, you can do everything except for the last section. Not right now, because we only got 5 minutes left, but I will give you time on it tomorrow. So you can go ahead and put away your stuff. Make sure you erase your whiteboards before you leave.